Good afternoon for everyone who is joining us today for this webinar hosted by PV Tech in association with TrinaTracker. Welcome to you all. My name is Ben Willis. I'm the managing editor of PV Tech. It's a great pleasure to have you all join us for what I'm sure will be an insightful and forward-looking discussion on how artificial intelligence is transforming solar plant operations. As we are all aware, the global solar industry is experiencing unprecedented growth. Utility-scale solar plants are becoming larger and more complex, requiring smarter and more efficient ways to manage and optimize them. This is where AI-enabled technologies such as smart trackers are stepping in to revolutionize the way we operate solar plants. To give you some context, tracker systems have already proven to be a game changer for solar projects, significantly increasing energy yields compared to fixed tilt systems. However, with the integration of artificial intelligence, we're entering a new era of operational possibilities, encompassing powerful predictive maintenance capabilities, real-time optimization of plant performance, and improved energy production. This is particularly important in today's energy markets where dynamic electricity pricing mechanisms are becoming more common. By leveraging advanced algorithms, AI-enabled trackers can maximize power production during high-value periods, significantly boosting the financial returns of solar plants. AI also enables large amounts of detailed plant data to be analyzed and turned into actionable intelligence, giving operators powerful new tools to ensure plants are kept running. In today's webinar, we'll explore how these cutting-edge technologies are being applied in real-world scenarios and bringing tangible benefits to plant owners. We'll also dive into some of the latest innovations, including TrinaTracker's upgraded SuperTrack 2.0 technology, which uses advanced algorithms to optimize energy production, and its new AI-powered tracker-level SCADA system, which enables pre-diagnosis of electrical component issues. We're fortunate to have with us today a panel of experts who will share their insights and experiences on this topic. Gonzalo Baselga, Head of Tracker Business EU at TrinaTracker, will discuss how TrinaTracker provides comprehensive solutions from product to service level to support clients during project installation and operation. Dr. Sun Kai, Head of Smart Tracker Control Systems at TrinaTracker, will introduce the upgraded SuperTrack 2.0 and the new AI-powered tracker-level SCADA system and how these innovations are driving efficiency and profitability. Finally, Manuel Lenas-Arbo, Regional Manager for Europe at Green Power Monitor, will share his expertise on how AI technology is benefiting solar power assets. So whether you're a project developer, asset owner, or simply someone interested in the future of solar technology, this webinar will provide valuable insights into how AI is shaping the next generation of solar plant operations. So without further ado, let's get started. I'd like to hand over to our first speaker today, Gonzalo, to kick things off. Gonzalo, over to you. Thank you very much.
Thank you very much, Ben, for your nice introduction. Thank you very much, PV Tech, for coordinating this webinar. It's my pleasure to be here. So Trina was born back in 1997. Since then, so the market has changed a lot. So has been facing a lot of changes. So I'm therefore here I want to highlight the four main changes that we are now, or the market is facing right now. Okay, so first, the pricing doesn't remain flat. So we shift from feed-in tariffs to PPAs, to power purchase agreements, to contract for differences, so even negative pricing. Then, therefore of that, so the customers, they are demanding longer life cycle assets. So the plants, they must remain longer to have better return of investments. So just to give you one example, so we are moving from 20-25 years warranty in the case of the trackers or fixed structures to 35 or even 40 in countries like UK and Ireland. And even when it comes to commercial components like motor and controls, we shift from 2 to 5, and even we are encountering 10 years request. PV plants, of course, they are booming, so the market is growing, and therefore, when it comes to operation and maintenance, the labor cost is increasing. And depending on the country where we are, so it's quite difficult to find people and companies that are providing such services. Last but not least, so the market is demanding not just hardware, product, and price. What the market is also demanding is service that is going to be provided during the whole life of the PV plant production. So therefore, having said that, what are the customers requiring currently now? So they want to reduce the capex of the installation, and of course, the quicker, the better we can commission the plants. Then, as I said before, so the customers, they are demanding longer life cycles of the assets, a longer life cycle of the assets, but where companies like Trina can provide a service to increase the LCOE of the plants. So as the operation and maintenance is increasing, so we are being requested to provide tools. My colleague Sunkai will provide more details that with AI tools, we can get some info from the plant and we can predict some maintenance just to reduce the cost of the operation and maintenance. And as the pricing, they are declining or they are becoming quite unpredictable. So we are not just being requested to increase the energy yield of the plants using the trackers, but also we are requested to improve the income of the plants. So just also by using IA, the technologies that they are crossing also with the electricity price. So why the customers, they are choosing TrinaTracker? So it's worth to mention that last year we were top 4 in the market, top 4 in Latin America, but also in Middle East and in Europe. In Europe, in the largest 2 markets, so Spain and Italy, we were even top 3 and keep growing. So from TrinaTracker, so we are controlling the whole in-house engineering, but also the product manufacturing. So this is not just related to trackers, how we are manufacturing, but it goes also about the consoles. Consoles like MCUs, like TCUs, and all the digital ecosystem that is interacting between the trackers and the operation and maintenance, which is the topic of this webinar, just to improve the response and to decrease the cost, the OPEX cost. It's well known that Trina is an international company. This is of course, but we know and we know that the market, what appreciates and the customer, what they are looking for is this pretty local approach. So TrinaTracker, we can manufacture trackers not just from China, excuse me, but also we are manufacturing trackers in Brazil, in Saudi Arabia, and also in Spain. In each single regions where we are present, so we have the key departments that they are providing the service that the customer they are requiring. Just to give you one example, so our tracker, as we have a broad expertise where we are installing and we are supplying trackers from US to China and of course in LAC, in Middle East and Europe. So we are preparing not just from the engineering point of view of following up, of course, the local codes, but what is more important, we are delivering the best service to the customers when it comes to checking the layout, geotechnical reports, and of course controlling the local snow and wind requirements of each single project, just to deliver the most comprehensive solution. Then products that Trina, so we have, beside of course the fixed structures that they are not applicable for this webinar for obvious reasons. So We have 1P and 2P trackers. Everybody knows that 1P tracker maybe is the most cost effective and maybe represents 75% of the market, but also 2P tracker has its own niche. So in countries like Colombia, Chile, Spain, and Italy, I would say, with challenging plots where we want to reduce the piles, when we want to increase the peak power install, I think this is always a good solution. When it comes to super track, so my colleague Sunkai will extend a little bit, but so we are increasing the yield, but we are also combining the yield with the electricity price to increase the incomes of the plants. When it comes to backtracking, so we have independent row-to-row system, but also we are combining the AI just to make sure that maybe we can shade the row and even getting more yield that if we wouldn't have shaped this kind of road. Then SCADA, we are providing and we are getting the inputs of the plan, so we can have the main technical inputs, and then we can provide with a predictive maintenance, so we can reduce the OPEX of the plant, again by using AI features. And as I said before, we are not just manufacturing in Europe, but also we have manufacturing facilities in Saudi Arabia, in Brazil and China, and we are expanding our facilities. So if we want to get a project and we want to service a customer, really what the customers they are demanding is a comprehensive service to them. So in each region we have the proper departments just from the beginning to be on top of the customer. So our pre-sales department is working with engineering and geotechnical department just to provide the better solution. Once we got and once we manufacture the trackers, they are being shipped, and then we can either make a supervision of the assembly by the customer, or even by our own, we can provide the assembly services. Commissioning. So we are expanding and upgrading our commissioning just to be able to make it on-site and remotely, to make an express commissioning and to make it quicker and to reduce the CapEx cost, which is the most important. And last but not least, so we are launching our service when it comes to operation and maintenance support, which is the Track Guard. With that, we want to decrease the OPEX cost, but to increase the LCOE of the plant. So we are remoting and controlling remotely 24/7 the plants. We are providing predictive diagnosis. We are increasing our spare part hub just to have a quick response. We are servicing the customers by going to the plant and trying some visits, and also training the local people there. So pretty much that's all from my side, Ben.
Thank you very much, Gonzalo, for that that introduction. Very interesting. Some interesting perspectives on how the market is changing. We'll drill a bit further into some of the technicalities now of today's subject. Sun Kai is up next, and he's going to talk us through some of the technical details of the SuperTrack 2.0 upgrades and AI-powered SCADA systems. So, Sun Kai, over to you. Thank you very much.
Thank you, Ben. Thank you for the warm introduction. Hello, everyone. My name is Sun Kai. It is a pleasure to be here today. I will walk you through how TrinaTracker smart control system has evolved, how it addresses the key O&M pain points in PV power plants, and how it enhances energy yield and the real-time electricity pricing, and ultimately how these capabilities bring greater value to our customers. First, let me briefly introduce the development path of the smart control system. Our work began in 2020 with the development of smart tracking algorithms and track controllers, forming the core foundation of smart control system. In 2021, we achieved two important milestones: the larger-scale deployment of first-generation track controller and the introduction of track-level SCADA system. Together, they established the system's first smart monitoring capability and marked a crucial step from prototype development to operational deployment. From 2022 to 2024, we continued to enhance the system by upgrading SuperTracker algorithm and introducing a cloud-based management platform. These improvements helped customers operate their power plants more efficiently. Despite these improvements, PV power plants still face significant challenges. Changing weather conditions and uneven terrains reduce power generation. Manual inspections remain labor-intensive and inefficient. At the same time, plant operators need to increase energy yield, protect equipment, and reduce O&M cost. These needs shape the direction of our solutions. In 2025, we are introducing several new tools, including a commissioning app, enhanced diagnostic capabilities, and tracking strategies designed for real-time electricity pricing. These features support more accurate fault detection and aim to reduce O&M costs while improving overall returns. With this context, let me present the overall architecture of TrinaTracker Smart Control System. TrinaTracker Smart Control System consists of three core components: Smart Controller, Trina Smart Cloud, and SuperTrack. Together, they provide a coordinated solution to the key O&M pain points. Smart Controller delivers high power output to support longer trackers and a rapid response to changing weather conditions. Its electrical multi-drive design also ensures precise movement and a stable operation. Trina Smart Cloud is available in both local and cloud versions. The local version is deployed in the central control room and supports private data storage. The cloud version allows remote access from any location and enables unified monitoring of multiple power plants. Key functions include remote parameter adjustment, multi-station management, and real-time monitoring. A pre-warning feature is also under development to detect issues before they lead to failures. SuperTrack includes STA and SBA. It collects data from weather sensors and analyzes terrain to optimize parameter settings and tracking strategies, boosting overall energy generation. This year, we also introduced tracking strategies that align track operation with the real-time electricity pricing to help maximize prompt revenue. Now that we have an overview of the system, let's look more closely at the typical O&M pain points and how diagnosis features address them. To better support our customers, we continuously study the practical O&M challenges that PV power plants face. These challenges fall into four categories, and we have developed diagnostic tools to address them. First, mode overcurrent can stop track rotation and lead to power loss or even structural risk. Routine inspections often fail to detect early signs. The mode health diagnosis of function identifies the risk in advance. Second, when communication is lost, operators must conduct on-site testing, which is time-consuming and inefficient. Communication health diagnosis help analyze the root cause more quickly. The next one is degraded batteries may fail during extended periods of cloudy weather. Traditional inspections may not easily detect the battery performance. The battery health diagnosis function provides direct visibility of battery status through Trina Smart Cloud. Last but not least, trackers are rarely installed with perfect accuracy. Small installation deviations can create long-term structural risk that are almost impossible to detect through the visual inspection. Track installation diagnosis is able to identify these issues. With Smart Cloud and the diagnosis functions, O&M can shift from reactive repairs to proactive management. This reduces workload and improves overall operational efficiency. SafeTrack also introduces global optimization strategies designed to align track operation with real-time electricity pricing. In addition to STA and SBA, new enhancements include the mini-shed model, axial optimization, higher limit angles, and optimized array spacing. These strategies can help increase power generation during high-value morning and evening periods. So what does this mean for O&M teams in real projects? Let me share some comparisons and results. Customer feedback shows clear differences before and after adopting Trina Smart Cloud. Without SCADA, inspections typically required 2 to 3 people conducting visual checks twice a day. If there were no obvious angle deviations, locating the faulty trackers could take 2 to 3 days. With SCADA, automatic alarms are generated. A single operator can review the alarm list and identify issues within minutes. With the diagnosis functions, potential risk can be detected even earlier, helping to further minimize losses. For example, early detection of motor oil leakage can reduce maintenance cost by 30% and extend the motor life by 1 to 2 years. Loose connectors or abnormal track angles can be identified before they lead to equipment damage or unexpected downtime. Cracks in most connections, often impossible to detect visually, but can be identified by diagnosis function before they cause short circuits or equipment failure. Based on these results, let me summarize the key advantages of the diagnosis solution. The new diagnosis function supports O&M with 3 main advantages. The first is suitable for all scenarios. It operates reliably in environments with large temperature variations, desert conditions, etc. The second is accurate pre-warning. Diagnostic algorithms detect fault signals in advance and identify hidden risks before.
I think we may have lost Sunkai's line there, but let's just give him a moment and hopefully it will come back on. Can sometimes be an issue. So Sunkai, I don't know if you can hear us, but maybe you could try turning off and on again. No, I think we've unfortunately lost Sunkai momentarily. So I think maybe we'll come back to Sunkai once we've re-established the line. So perhaps rather sooner than we might have expected, I'd like to invite Manuel up to the stage, and hopefully that will buy us a little bit of time to get Sunkai back on the line. Apologies to everyone. Sometimes we get these technical glitches, such as the nature of these webinars. But anyway, luckily we have Manuel waiting patiently in the wings. So Manuel, over to you. Thank you very much.
Thank you, Ben. I believe that at these moments we are thinking why AI do not help. No, in these situations, it will be super good. No, but so far, super interesting what Sankei was saying and also Gonzalo before me. And yeah, and super thank you for inviting me here and be able to contribute in this panel. Let me start saying that I am Manu with GPM, part of DMB Group, and GPM Horizon is the platform that we've been working on the last years, together also with our colleagues from DNB, to centralize and optimize the portfolios, not only for solar, but also for wind and storage. If we focus somehow on the general capabilities that the platform may have at the end, on this platform, we are offering a centralized visibility of your portfolio, providing a single access to your entire asset. Also, we have a ton of tools and advanced analytics that allow you to better track and perform the performance of your assets. Also, we put a lot of efforts on trying to optimize the resources. I remember that it was something that Gonzalo was saying. No, every time prices are more challenging, every time sending people on site, it's more expensive, and we are trying to reduce costs every single moment. So with the platform, we are trying to help on this optimization of the cost. And then altogether, we are offering customized views according the different needs of our customers, showing different KPIs, alarms, and other requirements that they may have in order to see the performance of their assets. If we focus on the trackers itself, something that we've been working is especially on the tracker availability. At the end, the platform now is able to calculate not only the availability based on just the pure status of the tracker, but also on the deviation of the tracker versus the ideal set point, that it can be something that the platform provides or even something that is coming by the tracker itself. And from there, we are able to, we allow the customer to modify the thresholds that will tell us how well, let's say, it's performing the tracker. Also, the tool is able to provide some suggestions, but at the end, we also allow to the customer to fine tune depending on the different requirements that each site or each section may have. At the end, also, we are also talking about optimization of our efforts and resources. So let's say that the platform itself is offering a portfolio level aggregation. At the end, with that, what we are saying is that the platform is able to consolidate all the data and being able to show where are located the problems, and from there start drilling down where the problem is exactly located, rather than having to be investigating across the platform or across the alarms. So with these general views, you are able to identify easier and faster where are the problems and be able to go straight on where your portfolio is being affected. All this, as I said, just to help on the efficiency of the operation of your entire portfolio. On top of this, and together with what my colleagues from Trina were saying, we are also deploying an advanced loss modeling. With this modeling, at the end, what the system is doing is calculating in real time the losses that you are having on your portfolio and categorizing them. We have a specific, let's say, category for the trackers, but there is even more. Also, this categorization is following a hierarchical approach, as we said. So with that, what we are trying to say is that there are no losses duplicated. In terms of, we are detecting 200 megawatts in tracker, well, maybe 200, let's say 200 kilowatts in a tracker and 200 kilowatts in the inverter. all the algorithm together with the artificial intelligence, it's fine-tuned so the losses are categorized to the element that it corresponds. And all together, it helps to the client to identify where is the biggest loss of their portfolio and helps to put their efforts on the biggest loss. Also, personally, I think that this kind of advanced modeling for categorizing the losses, it also helps on making decisions at the level. We are talking about trackers. We can also talk about soiling. When you are detecting soiling on the portfolio, you are able to make the decision if it's time to clean the panels or not. And the same on any tracker maintenance and so on. Based on the amount of losses, you can decide if those losses is the moment to get corrected, as that correction will compensate the amount of loss. Okay, so I think that these kind of views are super interesting to take decisions when you are operating large portfolios. And again, these categorizations are happening at site level, at element level, but also portfolio level. So when you are landing to the site, you are able to see how much you are losing because your trackers or because any other situation. Let me add just that I'm not saying that the trackers are the main reason. It's just because mainly here we're talking about trackers. Of course, there are much more reasons, and definitely I would say that it's not one of the biggest impacts, I would say. Then the added value with all this, at the end, it's what I said. We can be using custom KPI formulas to adapt according to your portfolio and your site needs. We have all the predictive analytics advantage, where it helps to determine where are the losses and how much are these losses. We have all the automatic reporting that it will simplify your life when you are reporting the wins and the losses of your portfolio to your board of directors, to your customers, to the asset owners, to the asset investors. I think that having this kind of automatic tools, it facilitates a lot the day-to-day job of the asset managers, okay? And all that at the end, if instead of spending time on making reports, you are spending time on locating where you can improve your portfolio, at the end, always it will bring value to the job that you are doing. Just as visualization tool, let me remark that at the end of the tool, we have this head map that displays where the tracker's availability is, and it helps you to put your attention and identify fast where is the problem. We have a couple of graphs where you can see the deviations between the tracker set point and the tracker current position to help on that. And last but not least, as I was commenting before, we have the waterfall chart that I think that will help a lot to identify and to quantify, I will say, those losses in order to be able to assign priorities and efforts to your portfolio to try to maximize the operation. That was it from my side, Ben. I don't know if we can give it back to Sankai to finish.
Yes, I think we've got Sunkai back.
Hopefully, yes.
Yeah, he joined back. Yes, here he is. So, Sunkai, yes, sorry we lost you then. We were all very interested to hear what you were saying. Unfortunately, the technology let us down, but I hope you can remember roughly where you got to and pick up where you left off. So back to you. Thanks very much.
Okay, sorry guys, sorry for the disconnection. So I'd like to check if my voice is clear right now.
Absolutely, yes, we can hear you very clearly. Thank you.
Okay, sorry. Okay, I will finish the rest part. Okay, so the new diagnosis function supports O&M with 3. Okay, so
Hello, yeah, you're good, yeah.
Okay, so right now it's clear, right? So can I start?
Yes, yeah, absolutely. We can hear you loud and clear.
Okay, yeah. Great. Okay, so the new diagnosis function supports O&M with 3 main advantages. The first is suitable for all scenarios. It operates reliably in environments with large temperature variations, desert conditions, etc. The second is accurate pre-warning. diagnostic algorithms detect fault signals in advance and identify hidden risks before failure occurs. The third is improved O&M efficiency. It shortens the time needed to locate the root causes and provides clear guidance, helping reduce power generation loss. The diagnosis function has been validated in real projects and is suitable for all types of PV power plants, including agri-PV, fishery PV, mountainous sites, and desert projects. We conducted 2 real case studies in agri-PV and fishery PV, respectively. In both cases, the diagnosis function identified interference and hidden faults that traditional monitoring systems could not detect. The first is agri-PV scenario. Motor current analysis revealed abnormal patterns. A site inspection confirmed that the vines had wrapped around the equipment. Cleaning the vines prevented the motor overload and reduced the maintenance needs. During crop growth periods, when field access is limited, pre-warnings help ensure timely action. The second is fishery PV scenario. Access to the site is difficult, making routine inspection very challenging. By detecting a combination of increased current and distorted angle signals, the system identified loose connectors, which were later confirmed by O&M team. The 2 case studies demonstrate how the diagnosis function enables early and accurate issue identification, even in complex environments. We have talked a lot about the new features in Trina Smart Cloud, and now let's move on to SuperTracker. Upgraded SuperTracker consists of 6 optimization strategies. Besides STA and SBA, here I'd like to highlight the other 4 major upgrades. First, the mini shading model, which allows to move tracker to a big angle position to shade half of the PV modules. Traditional backtracking reduces the track tilt angle to avoid shading, but a lower tilt also decreases the received irradiance and increases IM loss. SuperTracker uses a patented mini shading model that compares the irradiance loss from reduced tilt with the loss from the partial shading, and select the angle that maximizes total energy yield. In Changzhou, this approach delivers irradiance gains on a typical clear day, resulting in 0.92% increase of revenue when combined with the local real-time electricity pricing. The second is axial optimization, which is a brand new strategy for optimization. Conventional north-south arrays generate symmetrical energy in the morning and afternoon. In regions with real-time pricing policy, this does not maximize revenue. SuperTracker introduces an axial orientation offset to shift energy production toward higher price hours. For example, in Tangshan, a 20-degree west of south orientation increases morning generation and improves the daily revenue by about 10% compared with a standard north-south array. The third and the fourth are about system-level design optimization. For projects with large row spacing, increasing the limit angle extends the effective tracking period. In high-latitude regions, raising the limit angle to 75 degrees improves daily revenue by 0.5%. Larger row spacing also enables greater backtracking angles, increasing energy yield during backtracking periods, which often align with high price windows on the real-time electricity pricing. In Inner Mongolia, increasing row spacing by 1 meter improves the daily revenue by about 4.08%. The upgraded TrinaTracker conducts multi-scenario analysis for each project. This includes evaluating site location, diffuse irradiance ratio, terrain conditions, and the local real-time electricity pricing. Based on these inputs, the system selects and combines the optimization strategies that best match the project. This coordinated approach creates a tailored solution that improves long-term performance. For example, in Tangshan, electricity price varies with time significantly. To align energy production with high price periods, the solution adjusts the axial orientation. When combined with diffuse irradiance optimization, complex terrain optimization, and the mini-shading model, a hybrid optimization strategy is formed. To evaluate this, a comparison was made between a conventional array and a TrinaTracker array with a 20-degree west of south orientation, analyzing differences in tracking angles and annual irradiance performance. With analysis of the average irradiance distribution, the TrinaTracker array shows clear gains during morning hours and backtracking periods. The annual irradiance gain reaches around 2.68%. Because these higher irradiance periods align with high price windows on the real-time electricity pricing, the financial impact is amplified. Overall, the TrinaTracker array increases annual revenue by 5.14%. To conclude, TrinaTracker's smart tracking solution enhances PV plant O&M through two core capabilities: the advanced health diagnosis features in Trina Smart Cloud and the upgraded TrinaTracker optimization strategies. Together, these technologies support reliable operation, improve O&M efficiency, and strengthen long-term plant performance. That's all for my presentation today, and thank you for your attention.
Thank you very much, Sun-Kai. Really glad that you managed to get to the end of it there. So let's hope that's it for the technical disruptions. So we're going to just run through a few questions before the webinar comes to an end. So got a few sort of technical ones which probably are for Sun-Kai and possibly Manuel. So the first one is one about the cost benefit considerations of adding some of the technologies which we've been hearing about today, which obviously very sophisticated. They add significant capabilities to all manner of aspects of plant operations and optimization. But I would guess clearly, such capabilities would come with an additional cost, even though obviously they add value over the lifetime of the plant. Can you give a sense of how the costs versus benefit equation looks when introducing some of these sort of smart tracking and SCADA capabilities in a plant along the lines of the ones that you've been discussing today?
Yeah, Ben. So I think it's a very interesting question. Actually, the benefit of using such new technologies is closely related with the specific project conditions. For example, and also as well as the local on-grid price. I roughly estimate the investment return on the new technologies is about 2 to 3 years based on the annual energy gain of 2%. But the PV power plant will operate more than 20 years. Therefore, I think it's definitely a good investment for the power plant owners to purchase such new technologies.
All right. Well, that's a clear answer. Manuel, I mean, maybe similar sort of question to you. I wonder if, from the perspective that you come at this, you know, in terms of the sort of benefits that things like this add to profitability and operations and so forth, what your views are on the sort of economics of adding these kinds of capabilities.
Sure. Like, well, in reality, I think that it's a really interesting question. I always, on this, what I realized since I started in this business is that every time we have more and more and more data available, and this is happening at all the levels, no? Maybe 10 years ago from the tracker, you were getting mainly the position and then a couple of status. And now you see the signal list of a tracker and it have almost like 200 signals or things like that. And it's interesting. And at the end, the value that we are all together adding on that is more data. We are able to put more efforts on all these artificial intelligence that sometimes it looks like it's something Ethereum. I don't know how to say it, but the reality is that there is a lot of people working behind from GPM side, but also I see it from Trina, to add this kind of extra step where, okay, we are not just generating the data, we are analyzing all this data and trying to give you direct outcomes that at the end it's optimizing your solution, not anymore having an alert like, okay, tracker is off or tracker is stop or stuck. Now we are able to tell you at what time, how possible is that it gets stuck, what is the best moment to make a maintenance, what is the amount of losses that you are getting for certain thing, and all this at the end, it helps to optimize not only the asset itself, also the resources that you have to manage that asset. So somehow it's how I am seeing it.
Great, thanks very much. And I guess sort of continuing on from that question in terms of the adoption of these kind of AI-based technologies. I mean, I think it's probably fair to say that you know, we're kind of in the early stages, maybe the sort of foothills of what, you know, could be a pretty seismic earthquake in terms of how things are done going forward. What would you see as being the sort of main drivers for the adoption of AI-enabled smart trackers, SCADA, those kinds of things? And are there any perhaps sort of regions or markets where these technologies are gaining traction faster than others?
Okay, so you know, for the drivers of AI-enabled smart trackers, I think, from my perspective, I think building a power plant is a business, and the power plant owners always seek for a higher investment return. So reducing costs and increasing revenue are the two main directions. As I introduced in the presentation, SCADA system with advanced algorithms will improve the O&M efficiency and reduce O&M costs, as well as the cost of sensors, etc. AI-enabled smart trackers will generate more energy yield. As I mentioned in the presentation, so SuperTrack can greatly improve the energy yield. So together with advanced algorithms for improving O&M efficiency or increasing the energy yield, will further bring high revenue. So I think it's a main driver for, you know, for adoption of AI enabled trackers.
I see. Thank you. And do you think it will be a sort of even adoption regionally by market, or do you think there'll be some areas that will be kind of front runners in this, or does it kind of make equal sense everywhere?
Yeah, currently I think it's a global demand for these new technologies, no matter in Europe, in LAC regions, in Middle East, in China. I think it's a global demand, as I mentioned, because I think no matter in which place, So always seeking a high investment is always the ultimate goal for the asset owners. So for these new technologies, they are always expect and use them. So I think it's global.
Yeah, fair enough. Anyone else want to chime in on that question, or we can move on?
Not particularly. I would say that
Okay.
I would agree. It's something, it's happening globally. Of course,
Yeah.
I don't know. There are markets that are more early adapters, but I would say that nowadays the information flies, no? So even if you feel that there are some early adopters next week, the others also want it.
Okay, thank you. Just one more for you, Sunkai. One of the tools that you discussed in your presentation was pre-diagnosis. I think you called it as an innovation to save manpower costs during the operations and maintenance phases. I think you gave the example of sort of agri PV scenario. I just wondered if you could sort of take that a bit wider and discuss whether this is also a useful investment for sort of normal solar plants as opposed to these quite specific agri PV ones.
Oh, okay. So of course, yes, as I mentioned, it's in my presentation, pre-diagnosis is suitable for all scenarios because like mold issues, improper installation of trackers, communication issues, and abnormal power supply issue. For these issues, they are very common in the normal solar power plants. So once pre-diagnosis function is adopted, these issues could be recognized in advance, and further analysis and OM advice will be provided to help power plant owners reduce the downtime of the system and help them to save the cost. Of course, in this presentation, agri PV is just one of the typical scenarios, but actually it's universal for all PV power plants.
Lovely, thank you very much. Yes, so Manuel, maybe just looking at some of what you talked about for a bit, you discussed GPM Horizon's real-time loss modeling and hierarchical categorization. How do those improve operational accuracy and help with the prioritization of interventions across large portfolios? I mean, I guess that's a pretty key characteristic now of the way the market's going. Portfolios are getting bigger, they're getting more complicated. They cross sort of geographies and different market rules and things like that. Perhaps you could talk a little bit about how your system helps with that sort of complexity, I guess, that we're seeing today.
Yeah. Well, somehow I identify it as key, but mainly, as I was saying before, the systems are evolving super fast. Before we were doing reactive things, like if something breaks, we raise an alert. Now you're trying to be proactive. So for me, it's key somehow having a platform that is able to tell you where are you losing the money and how much you are losing. Because for me, now it's not anymore on, okay, I am losing 20 kilowatts, but somehow the platform must be able to tell you if those 20 kilowatts, it's something that you can recover. And then it should be easy for anyone using the platform to identify, okay, how much it cost me to recover those 20 kilowatts and how much it will pay me back. So somehow you're able even also to calculate the return of the investment, no? Because sometimes it's not even only making the decision, okay, I repair it or not, I repair it. The decision also must be supported on numbers, no? We are all in this business to make money. And I think that these kind of tools are key to allow the asset managers, the asset owners to make those decisions.
Great, and the customizable KPI formula feature as well. I mean, I guess that enables users to tailor performance tracking to specific requirements. Can you talk a bit about what impact that has on asset optimization overall?
Yeah, again, we are every time more and more, we have more tools, more data, but also we need to understand that we are coming from, let's say, rigid models, and now every time the models are adapting better to the reality of what each site is. And this is where custom KPIs are key. No, you cannot be considering a site with two axis tracker than a single axis tracker. How you calculate these KPIs, what you take in account, what are the values that affect, and so on. It's totally different. And then having this kind of features allows you to better tailor what the outcome of the platform is according to the requirements of those assets.
Great, thank you very much. We're getting a bit short on time now, but just a quick one for Gonzalo. I forget your precise words, Gonzalo, but I think you said something along the lines of how the market was now demanding a service more than just, simply the purchasing of a product. I hope I understood you correctly on that point. But in terms of TrinaTracker and the sort of service and support that you provide your customers, can you tell us a bit about that and your approach?
Yeah, thank you, Ben. This is quite interesting question. So just our approach, so we are listening to the market, just so easy like this. No? So I think Manuel was totally right. Everything comes about the IRR or the return of the investment. This is about money. This is actually solar itself is about investments. Okay, so actually our bunch of customers from Trina, they are all final owners or developers, IPPs, so they want to keep longer the investments. They are willing to get longer warranties. They are also willing to get more yield and more availability of the plant. And of course, so we are listening to the market, and therefore we are releasing this track guard service where we can provide a faster service when it comes to, for instance, so if something breaks down when it comes to the tracker, so we can provide quicker service for controls, so for motors. We are on top of the plant 24/7. So as Manuel and Sunkai was saying, so we are working much more on a predictive maintenance rather than a corrective one. So we can decrease the cost of the maintenance working with the AI and with the basic parameters of the plant. That, as Manuel was saying, step by step we have more and more data, so that we can work with. So, and at the end of the day, so what we are trying to provide to the customer is more availability, more yield, more income, so and to increase the LCOE of the plant, or to reduce the LCOE of the plant, so make it more profitable.
Which is what it comes down to at the end of the day. Well, thank you very much. On that note, I think that just about sums it up and brings us to the end of our hour. So thanks to everyone. I think what we've heard today illustrates just how essential and fundamental AI technologies are going to be to the next generation of PV power plants, whether it's diagnosing component failure or pre-diagnosing even, to maximizing the value of solar in today's complex energy markets. It seems certain that AI-enabled technologies will play a significant role in the future of our industry. So I hope you found this webinar informative and stimulating. Recordings of the presentations and the slides you've seen will be emailed to webinar sign-ups in the next few days. It will also be available shortly on PVTech's on-demand webinar section, so look out for it there. If you've asked a question we didn't manage to get to today, please feel free to follow up with any of our speakers to keep the conversation going. So all that remains for me is to thank our panelists today, Gonzalo, Sunkai and Manuel, and for your presentations. And of course, to our sponsor today, TrinaTracker. From the team and me at PV Tech, thank you for joining us today. Wishing you all a very productive and prosperous 2026. Thank you and goodbye.